Assalamualaikum warahmatullahi wabarakatuh and very good morning to the honorable panel. Today I would like to present my final year project entitled Wind Tunnel Test of Short Fuselage Blended Wing Body with Twisted Wing. Before I start my presentation, I would like to introduce myself. My name is Muhammad Hazrul Kushairi bin Muhammad Rohani from Faculty of Mechanical Engineering, and my supervisor for this research is Professor Dr. Wirachman Wisnu. Okay, firstly, I would like to start with the background of the topic. Okay, so what is blended wing body? Okay, blended wing body aircraft is a tailless aircraft have a fuselage and wing design resembling a flying wing. Okay, so next one. Based on the previous journal that I have been gone through, or previous journal and article that I have been gone through, it is proven that blended wing body have lower fuel consumption, maximum takeoff weight, and low operational cost compared to the conventional aircraft nowadays. So it can be said that the concept of blended wing body is a futuristic for the aviation industry due to its some of the advantage that I just told before. Okay, so next one is blended wing body consists of two sections, which is the center section and the outer section. Okay, so as you can see from the figure beside here, there are three sections. Okay, first the outer section is the main wing, and the center section is the center body or the fuselage and the blending area. So as we know why it is called as a blended wing body aircraft, because the main wing of the airplane is blending to the fuselage or the center body. Okay, next in this research, I will use the fuselage short fuselage body for the blended wing body aircraft. Okay, three types of model were used to analyze on the wind tunnel, where each of the model have a different twisted angle on the wing. Okay, twisted wing angle means that the airfoil at the wing roots was held in place while the leading edge of the wingtip airfoil was rotated from its center of rotation at the trailing edge. So, what is mean by is that the twisted uh, angle happen at the end of uh, the aircraft wingtip. So from the below of here, you can see there are three type of model which have a different twisted angle. So the 4 degrees not showing much of the twisted happen. So if you can see from the 6 degrees and 8 degrees, they are slightly different happen, where the wingtips at the aircraft have a slightly angle. Okay, next one is the problem statement. Okay, there are two main problems that I had found that in this project. Okay, so firstly is the result of the CFD simulation need to validate through a wind tunnel test. Okay, as you know that this research project had been carried out by the previous senior, but they used a computational fluid dynamic simulation analysis to obtain the result from these three type of model of the blended wing body aircraft that have a different twisted wing angle. Okay, so in order to uh, validate whether the result is acceptable or not, we need to carry out the test on the wind tunnel. So from there we can obtain the two result, and we can compare and see whether the result is acceptable or not. Okay, so next one is the aircraft will stall when it reaches at a certain angle of attack. Okay, so compared to the other type of fuselage, the short fuselage blended wing body tend to stall easily compared to the other type of length of fuselage, which occur at the wing section. Okay. Okay, for the objective and expected result. Okay, firstly for the objective is there are three objectives in this research. So firstly is to compare the result between the CFD simulation and the result test in the wind tunnel to validate the result obtained from the CFD simulation. Okay, next one is to obtain the value of drag coefficient, lift coefficient, and pitching moment coefficient from the wind tunnel test. And lastly, is to create a blended wing body aircraft model using a 3D print process. Okay, for the expected result is to obtain the lift curve, drag curve, and pitching moment curve for the twisted wing based on the result obtained from the wind tunnel. Okay, and next one is identify the best angle of wing twist that can offer best aerodynamic performance. Okay, so for the scope of work, there are three scope of work that uh, will be applied in this project. Firstly is to customize, which is to customize the CAD drawing of three different twist wing angle to test on the wing tunnel. Okay, so the drawing that provide from the previous research, I need to customize in terms of the dimension and the size of the wing body model aircraft. Okay, next one is to fabricate the blended wing body aircraft. We need to fabricate the model for the experiment in the wind tunnel. So this the process fabrication that we use is we're using a 3D printing process. Okay, next one is to analyze the data curve obtained from the wind tunnel experiment. Okay, so next one is the literature review. Okay, the first subtopic is the blended wing body aircraft. Okay, so blended wing body aircraft is an aircraft that combines wings and fuselage to form a single lifting body. Okay, a blended wing body is an idea that combines a conventional tube and a flying wing aircraft. Okay, so some of the advantage of the blended wing is that they, they are able to reducing 15% in maximum takeoff weight, 33% reduction in surface area, and 27% reduction in fuel burn per passenger mile. So next one is this when this aircraft is able to produce much lower noise and less pollutant compared to the conventional aircraft nowadays or the other aircraft. Okay, next one is the wind tunnel experiment. Okay, so this experiment was referred from the previous article, which is titled of Wind Tunnel Test of UITM Blended Wing Body Unmanned Aerial Vehicle Prototype. Okay, so for this experiment, in order to run the uh, blended wing body aircraft, the prototype need to scale down at 25% of their original size, and only half side of the model is used to test on the wind tunnel. Okay, uh, type of the wind tunnel used is the low speed wind tunnel with area section of uh, 500 0.5 meter times 0.5 meters times 1.25 meters. Okay, the main objective is to measure the lift coefficient, drag curve, and pitching moment curve. Okay, so as you can see from the table figure below, there are three types of graph against the angle of attack. Which firstly is the lift coefficient, pitching moment, and drag coefficient. And the figure above shows a model of the blended wing body that used on the wind tunnel. So this blended wing body has a canard design. It's the aircraft stall. Okay, the stall is an airflow effect that happens when an aircraft passes through a critical angle of attack and cannot create a lift beyond that point. As the angle of attack increases, the aircraft will decrease frequently. So based on the figure beside here, show that as the angle of attack increase to 20%, the separated flow region expand and will reduce the lift force of the aircraft. Okay, so next one is the aerodynamic on aircraft. Okay, aerodynamic is defined as a force exerted on a body by the air where the body is submerged between the and attributable to the relative motion of the body. Okay, the force consists of four general forces, which is the lift, drag, thrust, and weight force. So next one is the methodology. Okay, first step of this research process is the literature review, followed by the preparation of the CAD drawing of the blended wing body model, and next one is the fabrication of the blended wing body model. Okay, and followed by the wind tunnel testing, and the data and analysis obtained from the wind tunnel test, and lastly is the report writing. Okay, for this semester, I'm able to achieve until the fabrication process. Okay, first, the drawing need to be scaled down until 24% of the original dimension, which is referred to the previous research drawing. Okay, so this is to ensure that the model can fit in the wind tunnel. So next is for the fabrication process. Uh, I'm using a 3D print process. Okay, the CAD drawing need to convert to STL file first before starting the 3D printing process. Okay, the type of material used for the model is PLA filament with an infill of 20%. Okay, in future, the material will be added with fiberglass coating to strengthen the model to ensure that it is able to withstand the high wind force uh, on the wind tunnel. Okay, so for the wind tunnel process will be done on the next semester since uh, I'm having it is hard to use the workshop at the UATM now. So here are the blended wing body model drawing from the by using a SolidWorks. So you can see that the length of the model is about 296 millimeter with the width of 174 millimeter and have a thickness of 44 millimeter. So here are the preliminary outcome. Okay, that the model had been achieved. So for the brown one is the 4 degrees twisted angle, and the red one is the 6 degrees twisted angle, and the gray one had 8 degree of twisted swing angle. So these three model will be tested on the wind tunnel in future. So next one is the project planning. Okay, so as you can see, the first uh, step is the first step is the literature review, followed by the preparation CAD drawing, and the next one is the fabrication bended wing model. Okay, so the wind tunnel test will be held on the next semester as in planning, and the report writing was for the proposal uh, start at the on the end of May. So based on the project planning, most of the plan that I am set was able to achieve on time. So that's all from me, and thank you.